This talk is primarily going to be a quick covering of the stuff that we haven't been able to delve into more deeply throughout the last couple of days. So, some of the things that we haven't talked about are what to do at the command line, because there are a handful of different functions that you can do at the command line to do either a quick and dirty analysis without writing a script and whatnot. You just have a data file and you want to know what's going on there, have a little bit better idea of what's going on. Or we'll delve in a little bit with the graphical user interfaces for YT. And then I just want to mention that some of the stuff that was discussed earlier today in the Glean talk, there is the ability to do in situ data analysis, at least currently working with Enzo, and we're trying to flesh that out to work with some other different grid-based codes. But at this point you can do it, although I'm not really going to get into it. But there's some documentation on the wiki, not in the standard docs. And there's some documentation in the Enzo doc, the docs for Enzo. But anyway, okay. So let's get on to what's going on here. Oh, why do I still have... What is volume rendering off-axis projection? Well, don't worry about that top line. I'll modify my script, or my slides. So how do we use command line functions? There's a full description of command line functions on the documentation site that you can access if you need to. But for now, we'll go through it together. So at a command line, wherever, just type YT help, and it's going to give you a list of different commands that you can run from the command line just by typing YT and then a command. So people done YT help? It's not too challenging. Yes, awesome. Okay. So there are a bunch of commands. We'll go through a few of them here, but let's just YT help, and then so we get a whole bunch of commands here. YT update we've already addressed. It's how to update your source and rebuild the state of the code. There's load, so you can automatically start a IYT session with a data parameter file already loaded into space. There's YT hop, so you can automatically find halos. There's YT plot that automatically does some plotting of your slices or projections, so on and so forth. So, and we've already dealt with pastebin and pastebin grab and upload image. And so anyway, so let's do some stuff here. Oh, and for any of these commands, if you do YT and then the command that you found in help and -- help, it'll give you all the different parameters that you can set for it. So, one, just do YT stats on some data file. I just chose arbitrarily Enzo64 DDO39. But that just gives you, like I said, this is really good for just getting quick and dirty. You want to figure out what's going on with a data file. So if you do YT stats, that's going to be the equivalent of running print stats in a script. So has anybody done that? I mean, I can do it if you want to see, but stats. So it spits out all sorts of stuff on the scale, where the maximum density point is, and all this and the other. So it's kind of useful to figure out what's going on. Well, type in YT stats -H. Yeah, I don't think there is any. He just wants to know, Devin wants to know if there's a way, are those just the fixed statistics that you can get, or is it parameterizable? Yeah, that's all you get. If you want more detail, this is quick and dirty here we're talking about. You could modify the... Yeah, you can... That's right. You could update it to add additional statistics. Okay, so YT... Oh, yeah, question. Oh, with print stats? print stats doesn't work on flash data right now. Okay. Okay, that's good to know. We'll have to correct this. Okay, so then there's YT hop. So somebody can do that, and that's just going to run the hop halo finder on whatever data set and give you, with some kind of intelligent defaults, it's going to give you the data set including each of the individual halos, their center of masses, and so on and so forth. So it's useful to be able to check this out really quickly. You guys, I'm not going to go into this because we covered this yesterday, but I wanted to include it in the slides. This is the rendering that we did using YT space render. And there are lots of command line options that you can specify with that particular render function. Let's do YT plot. YT plot is pretty cool if you just want to get a plot collection with slices or projections along the different axes. So X, Y, and Z. You can specify a color map, as I did here, color map hot. And, it's very quick to get an idea of what's going on with your data set instead of having to sit down and make a script or go into IYT and start typing in all of these different commands. It's just really clean and really easy. Okay. Let's continue. Okay, so now we're getting to something pretty cool. There are two graphical user interfaces that are built into YT. This is the most lightweight, but also the quickest to run, and it's basically a Google Maps interface. So there's full description of this if you go to this website in the documentation. There's full description of how to use this and whatnot. But what you can do, if you just type YT space map server and then some data set that you have and hit enter, it specifies defaults. It'll give you the density field, and it'll go along the x-axis and that sort of thing. And of course, and it'll do a slice through that data. You can specify different things. You could do a projection or go down a different axis, but let's do that here. So YT map server, and then so it asks you, it says listening on HTTP, basically the local host. Then you can go into your web browser and go to that particular location, and poof. Now we have a Google Maps interface that I can pan and scan and zoom. This isn't. That's right. So this just isn't at a particularly high resolution, but here, let's do that again with a different data set. Why did it not do that? What did I do here? Is that a galaxy? It should. Gas sloshing all up purple. Say that again? To do this remotely, yes, you'll have to tunnel through. You have to make an SSH tunnel through to the system on which you're remotely connected to in order to do this. I'll show you. Reason it's a little bit more well documented because this is something that we're playing with, but I'll get to that in just a second. It is possible, but it's a little bit trickier for the map server because it's not as polished as Reason has been. So is everybody able to do something like what I was showing here? So you, it's not working for gas sloshing? Okay. Okay. Okay, so let's keep moving. So this is a nice way, again, of, it doesn't have a lot of features built into it. You can zoom in and you can move around pretty quickly, and also potentially let some collaborators see your data sets very easily and get a better idea of what's going on. But you can't switch fields on the fly. You can't do these other things on the fly, which would be nice. So now we've got Reason. Reason is a web-based graphical user interface that we put together in the last year or so. And again, there's a link here that describes how to use it effectively. There's also a screencast that's up there that's okay for explaining how to use it and use some of the defaults associated with it. So if you just type into your command line YT space serve. In a version I just pushed earlier today, we're also going to have it so you can type YT reason, but that shouldn't be in your version yet. So just type YT serve. And what will happen is it will... Here, let's do it. I'll do it along with you guys. YT serve. So it spits up all this business. Basically, just take your... just copy the link that it gives you and put it into the... When it says please direct your browser to, do that. And I recommend using Chrome. You can use Firefox. Sometimes it'll hang a little bit. We haven't tried it with Internet Explorer. And I don't know. It tends to work the best so far with Chrome. Haven't had any significant issues. So are people able to bring this sort of thing up in their web browsers? Is anyone having problems and needs some assistance? Really? Yeah, it might take a second. Casey, do you need help? Model to... He said no. Are you... It may... That's right. Raise your hand if you're still having problems, and we'll get someone over to assist you. So, is everything, you guys okay? Okay, sweet. Okay, so, well, no, I'll just keep demonstrating it. Basically what you want to do, so this is the overall interface here. You can type commands in the YT input, and you treat it as though you're dealing with a command line, a Python command line. And in order, just pressing enter won't do anything. That just gives you a new line. So hit shift enter to actually execute something, and it should spit something out down below. So for instance, you can do, pf equals load isolated galaxy. What's the rest of that file? That's correct. That's correct. So, yeah. So for those of you who didn't hear, all of the paths are relative to where you launched YT serve from. So I could hit enter, but it's not going to do anything. I hit shift enter, and then it executes. Shows down here in the console in the output, and you see this cool thing on the left side. Now this shows all the parameter files that you've loaded into memory. So you can put multiple parameter files into memory at the same time and then access them. You can right click on that now, and let's just look at the grids. So we look at the grids, and then using your mouse or your touchpad, you can zoom in here and look at and drag around and look at the grid structure for where the grids were done in this particular data set. Yes. Okay. So be careful. Okay, don't use this feature if you have an enormous simulation as your data file. Yeah, it'll just be too slow. Right. So the cool thing here is we can switch back and forth between what's going on at the console as well as the window that we had. So this is all done using JavaScript and Python to link your local version of YT through JavaScript into your web browser. So let's right-click on this again. Let's open up a slice on this data set. So we've got some defaults. You can center on the maximum density spot if you wanted to, or you can leave it to the defaults or change them. And then you can specify the axis. So again, this isn't off-axis stuff. This isn't cutting planes. This is just slices. And you can specify whatever field, and it picks up the fields from the parameter file that you're using. So let's just use density. Let's use the defaults here. So it takes a second. And poof. Now we have a slice. Now unfortunately we can't do like we did with the map server to drag it around. But what we can do is use these handy dandy little arrow keys over here. And zoom in by 10. Whoa, there's a disk. Zoom in by 10 or zoom out by 2, something like that, and move around this data set. As you can see, there are color bars on the right side which are automatically updating to the data set. And if we really want to, you can run this Pannable map button in the corner, and it brings up the Google Maps interface for this particular parameter file. So you can still do that cool stuff, but you don't have to. If you like a particular image, you can run the Upload Image button, and it'll spit it out. Let's not go to this link. But potentially one could, and it would be this particular image that we zoomed around in. Now the really cool thing about this, in my opinion, is that you're moving around through your data set, and let's say I really like this feature right here. So I'm gonna, this works in Chrome, but it doesn't work in other browsers as far as I know yet. If you do Command and then click on a spot, it recenters on that location, which is really useful. Instead of just trying with infinite number of arrow clicks to get, if I want to get to that location, it recenters on that location. You hold down the Command button, or I guess it depends on if you're using a Linux, but for Mac, Command and then left click will get you there. Perhaps it's Alt if you're using Linux. Yes. Yes, I am. But before I get there, what I wanted to point out is that, so let's say you're really interested in this particular feature, so you zoom in a bunch, and now this is the image that you want to include in your publication right here, this pixelated image of the disk. Not only can you upload the image, but you can save the script. Each time you made a click or pushed on one of the buttons, it recorded in a log file what you were doing. So now you can record the script that got you this exact image. You can save that to... Yeah, I know. I need to be careful here. So it just saved the entire basically Python console data that you did graphically here, so that you could rerun that in a Python script and it would bring up the identical image to what you're seeing here. It'll look ugly though. Not always. Oh, you mean the script looks ugly? Yeah, but the data, you get the exact same data out. Yes, that's right. So that's really useful to be able to try and find a particular feature and then try. You don't have to work to reproduce it later. You can just save that script and use it later. So as Jeff was calling attention to the data on the right side, it shows you the current field of view at which you're looking here, and it shows you the minimum and maximum value of whatever field you're projecting or slicing on. And that updates my browser isn't big enough here, but that updates as you move around. So we're looking at 2 kiloparsecs. Let's zoom out by 10 times. And now we're looking at 20 kiloparsecs. So this will change appropriately on the fly as you move things. And also something that you can't necessarily see, because again, my browser isn't too big, is down below, we see that we're looking at the density. The cool thing is when it loads in the parameter file, it sees all the fields that are defined. And we can switch this to whatever we want. So let's look at what the, I don't know. Let's look at temperature. I like temperature. And so for that exact same view, this is the temperature map for that particular slice. So it's very handy for analyzing your data and investigating your data to see what, how it's really operating. What's that? Exactly, in a group meeting, and then you could do everything together, and your advisor might say, well, what about that feature? And you can actually follow up on it instead of saying, oh, I'll have a script for you tomorrow after I go and look at that particular thing. You could do it right on the fly. So we did a slice, you can do a projection, and so on and so forth. So it's a very useful tool for doing this. And again, we can go back to other windows that we did earlier. But I think potentially the coolest aspect of this is something I'm about to show you. You aren't necessarily tied to doing this locally. You can access data that sits on a remote machine, like Molly was asking about with the map server. So let's quit out of this. Oh yeah, and you can go to IRC if you really want to. But you guys are already on IRC. So we'll quit this. Goodbye. And all right. So as I was saying, most all of our data is done non-locally. We run it on supercomputers wherever, and those data files can oftentimes be huge. So you don't want to download it all the way to your machine just so you can look and try and investigate it. You'd like to let it sit, your several gigabytes of data sit on the remote server and then access it in situ. So Reason allows you to do this. And what you need to do is log into your remote machine and do so with port forwarding on, so -Y, so SSH -Y or -X, and then the local or the remote system. So once you've done this, then do YT serve. So that's what I'm going to do. I just happen to have a Nautilus session here, and I'm in a directory, actually in Britain's data set, Britain's directory that has all the data sets from the meeting. And so you hit YT serve, just as we did locally. But this is on Nautilus. And you get the same thing that pops up to your screen. Now follow the directions here. If you're currently SSH'd into a remote machine, you should be able to create a new SSH tunnel by typing these commands. So hit ~C, just as it suggests here, which I did, and it opens up this nice little SSH terminal, so we're dealing directly with SSH. And then copy this into place. So now we're forwarding port 59567 from Nautilus to our port 59567 on this local machine. And then finally, we have our web browser go to this particular location, which is now on the local host. Because then other people can access your, yeah, right. So it's a one-time password. So it is secure, and you're not going to, only over SSH. You're not going to upset people by doing it over SSH because it's encrypted, but otherwise it would be bad. We go to that, and it loads up Reason. Now this looks identical to what it did before, but this session, although it's being accessed by my web browser locally to a port locally, that port is actually forwarding data from Nautilus. So I can access data that's sitting on Nautilus right now. And interestingly enough, it's pretty fast because all of the data that's going between Nautilus and this machine is in the form of images for the most part. And images are relatively quick to transfer. So again, we'll do load, what was it, isolated galaxy. What was it again? Galaxy, oh, thank you. 30. Loads up. And again, we can do, let's do a projection this time. So you can see it's kind of working down here. It's doing the projections, and boom, we have a projection in density. And we can still, there's also this this little knob at the bottom to designate your zoom in an analog manner, as opposed to just the zoom in by discrete values. But you can see that it's still quite fast, as fast as it was locally. So it's very useful to not have to download all your data and then poke around in it with scripts and whatnot, if you can just do this interactively. So there's active work being done to include more widgets instead of just projection and slice. It'd be nice to do this with volume rendering, to do this with off-axis projections, cutting planes and that sort of thing. But we're not there yet. So stay tuned, because this is an area of active development. Any questions? Oh, if you hit tilde-C, which it shows in that window. Here, I'll just cancel this. No, that was probably a mistake. If you get into problems and Control-C doesn't work, you can always suspend and then kill it. So if you do YT serve, it pops up this and it says if you're currently SSH'd into a remote machine, which we are. Yeah, I know. We're goodbye reason. Then you hit tilde-C, capital C, and it opens up that little SSH prompt. Matt or Britton, can you help him, please? What's that, Nathan? It only goes over the SSH. Yeah. No, so far we haven't meddled with doing time series through reason. Although, you know, at some level you could load in multiple parameter files simultaneously and then do similar analysis on each of those, but that would be a little bit slow. So it's tilde capital C. Yeah. It's not. On what system is? Oh, well that's why. You don't need to do the tilde capital C unless you're on a remote system. So when it pops up, it'll say, if you're on a remote SSH, then do these commands. But you don't need to do that because you're not on a remote SSH. You don't need to port and make a new for. So just go to above that. It gives you a URL. Go to that URL and it should work fine. Right. Are there any other questions? Oh, yeah. Say that again. Oh, this one? So you can grab that and put it into your web browser? Put that, yeah, just copy this and put it directly into your web browser URL. Like open up a website and go to that. Are you on a remote machine? So if you're on a remote machine, if you're currently SSH'd into a remote machine, then type in tilde capital C, and that'll open up this little SSH prompt, and then you can just copy and paste the -L 33730. That basically creates the tunnel between the remote machine and you to forward everything that goes to that port on Nautilus or Kraken or whatever is your remote system, and it will port all of that stuff to the local host. to your system on that particular port. So that when you go to this web location, which is coming from the local host's port, it's getting the data that's actually being generated on the remote system.
The only data that's passed back would be either the grid vertices, because those have to be split locally, or the data source.
Right.
Only the stuff you see can be passed back.
Only the stuff you see is passed back. Sam, do you have a question? Okay. Okay, any other questions? Yeah. Not yet. So the question is there a way to see in reason the current centroid of the location that you're looking, at which you're looking? So right now it just gives you the field of view, and it gives you the maximum and minimum of the field that you're projecting or slicing through. But it doesn't give you the centroid of the location. But that is something that we should do, because that would be very useful to know. Yes? The answer to that question. So yeah, we're working on something that's going to get a fixed resolution buffer out of Reason on the fly, with that information in it. All right, I'm going to end there and let you guys continue to play around with this if you want.